This is question number 9 from the packet I gave you. And the information you're given is there are 16 total students. 12 take art, 8 take music, and 1 takes neither. And then part A, you're asked to figure out what these 4 numbers are. And right away, we know that S is the one who takes neither art or music. And what that means is that there are now 15 students inside those 3 areas. And to figure out Q, what you notice is there are 12 students who take art and 8 take music. So according to that, 12 plus 8 equals 20, but there's only 15 total students, so we must have counted somebody more than once because they're in the intersection, and that 15, the total number of students, means that 5 got counted twice. So Q is equal to 5. That being said, then that means P, so take away the 5 from 12, and P is 7, and take away 5 from the 8, and R is 3. So there's part A. We now have the numbers. Part B asks you to find the probability that, given that you pick someone who takes music, that they take art. So what's the probability that the person you select takes art, given that they take music? And so the given that means, you know this person takes music. And so out of how many students do you have to choose from? You only have 8 students to choose from. That's the probability, or the given part. And then of these 8 students, how many are taking art? And that comes back up here to Q, which is 5. And so there's a 5/8 chance that people who are picking someone out of the music group, they also take art. And then part B is show that art and music are not independent. And again, that goes back to our formula booklet and this rule about independence, that the probability of A intersect B is meant to equal the product of the 2 probabilities. So the probability that you select someone from takes music and art, which is A intersect B, the intersection, that's going to be 5 out of the 16 total students. And the probability you pick someone who takes art, well, that's 12 out of the 16. And multiply that with the probability of choosing someone who takes music, 8 out of 16, and we find out that we have 5/16 equals, and I'm going to actually simplify that. That's a half, and this is 6/8, 3/4, but I'll leave it that way because we have 6/16. When we multiply, that does not equal, therefore these 2 probabilities are not independent. And again, showing that is going back to the formula booklet, finding the right formula, and then doing calculations based on that information. The last question, letter C, says 2 students are chosen. What's the probability that the first student you choose only takes music, and then the second student that you choose only takes art? And so when I think about this, we can think of a tree diagram to illustrate this. And so what that tells me, clues me into, is I'll be multiplying these 2 probabilities. There's also what we call the AND rule. And means that you should multiply the events when we talk about using the word and. So the probability that the first person I choose only takes music is 3 out of 16. So only music is 3 out of 16. Only art, so that they only take art, is 7 out of, now, you want to say 7 out of 16, but you have to realize the first person you picked was only music, so there's one less person, and there's sort of the catch to this question, that really the chance that you're going to pick someone who only takes art is 7 out of 15. And so now this probability is equal to the 3/16 times the 7/15, and I can just do a little counseling here, 3 and 5, so I have 7/80ths. And so that's how you calculate this probability, and it's really here the idea of these two probabilities are connected by the word and so and